Hello there. So I just want to show you a short demo and some theory around how Cerebral 2 works with React Fiber, because it actually works really well. Um, so if you haven't heard about Cerebral before, I'm going to give you a Cerebral 101 course, because basically Cerebral is like a controller um, that handles all the state changes and side effects of your application. When you create your React components, they are actually registered to what we call the container. So the container is like a wrapper around, it's a component in itself, and it knows about all the components in your application. So when a component mounts, it registers to the container, and that allows the container to know what state dependencies every component has, and it's actually the container that tells what component to update, to render. And this is quite different from other solutions, where you typically would listen to state changes and the components themselves would figure out if they should render or not. But a simple state change isn't enough to understand if like how it should update in terms of React Fiber. Should it be a deferred update or should it be a completely synchronous update? But since it's the container that tells the components to update, it can inform the component about the changes that has been done, including if it should be a deferred update or not. So the point here is that when a component triggers a Cerebral signal, it triggers something we call a function tree execution. And the function tree execution is basically just a tree of functions. And these functions gets a context injected, and the context contains APIs for whatever you want really. But by default, it's for changing state. You can add like HTTP requests, Firebase, whatever you want really, whatever side effects you want. And then it runs through these functions, and the function tree will emit events, which the container kind of like listens to. And whenever there's a state change, the container informs the component you should render and you should render based on what has changed. Now, the point is that we do, like by default, we want everything related to some asynchronous thing happening. Everything after the asynchronous thing is valid for a deferred update. Because if something first occurs asynchronously, we don't care when the UI updates. Like if it takes 1 millisecond or 100 milliseconds, it doesn't matter, because you probably have already waited a few milliseconds for it to be processed. So if we jump to the second slide here, let's say the second function in this function tree is an asynchronous function. Now, if the first function had a state change, that would run through synchronously, also to the components, because the function tree execution isn't identified as asynchronous yet. But when the second function runs, all other function executions after that will be asynchronous. And the container knows about this. So when there's a state change in these other functions, it will also inform that this was part of an asynchronous execution, meaning that the components will have a deferred update. So you kind of like just get this out of the box. You don't even have to think about it. Now there might be situations where you do a synchronous signal or function tree execution, and you do want a deferred update, and that is something to explore, like adding APIs to that. But the cool thing is, by default, you would just get a very optimized UI, because we control all the side effects and everything. So we know exactly when these deferred updates should be triggered. So let's have a quick look at code. I have the Fiber example running here. I don't know if you can see on this recording the janking that happens here. And I'm also running on the low resolution due to recording a video, which reduces the janking. So you just have to trust me. There's some janks here. So if we take a look at the code here, it's the demo, like the React Fiber demo, but I've refactored it so that the main application component connects to the Cerebral controller, where it grabs the seconds. But it's the exact same code. And then we have, in the script file here, we have the Cerebral controller. It has the second state, and it has one signal. And currently I have commented out an asynchronous execution of a function here, which means that this signal runs synchronously, which means that the component instantly updates, which means it's in risk of having janks, as you might have seen now. Now, if I remove this and I save, and it recompiles the demo, and it should soon update. There it updated. Now there's no janking at all. And that is because the Cerebral controller identified the first function as asynchronous. So when the second function ran, and made a state change, it informed this container component that is responsible for telling the app component that it should render, that you should now defer this update. So this is actually pretty cool. And I was really happy when there was so much talk about the internals of React Fiber. When I understood that it basically was a callback, like request animation frame. It's just like request idle time, or I don't remember the name of it. It was like just a perfect fit for Cerebral. And then it's more like these special scenarios where you do want synchronous execution to be deferred for some reason, but you get a lot of optimizations right out of the box here, which is really cool. And I think that is very unique for Cerebral because of function tree. It knows, it does everything for you. It does all the state changes, all the side effects. So it knows everything that happens inside your application and can identify when to optimally render components. Okay, thanks for having a listen and a look, and have a nice weekend.